Good evening, everyone. Have you ever been approached by someone who was talking about nanotechnology and you didn't know what to respond? Well, if I believe Niels Boeing, who will have this talk now, you will after this session. Enjoy.
Okay. Okay, hi everybody. Thank you very much for coming. It's very nice to be here and tell you a bit what nanotechnology is. I think many people know a little bit. They know that it's tiny, but then that's all. And probably the most important step in nanotechnology was the release of the iPod Nano, so that everybody knows, at least at the moment, oh, there is something like that. Just a word to on the picture you see there. It's a gold particle. It's, you see the scale in the upper left corner. It's really very tiny. And what you see there is actually the atom layers. It's an electron microscope image. And, well, you can do some nice things with this. But let's start then. So maybe the first occasion when somebody had the idea that you could do something like that with atoms was the physicist Richard Feynman. Maybe somebody knows him. He was a very important and creative physicist of the 20th century. And he said in 1959, in a lecture that was also between Christmas and New Year's Day at the Caltech, the principles of physics, as far as I can see, do not speak against the possibility of maneuvering things atom by atom. At this time, this was really a crazy idea because there were no tools, not even on the horizon, with which you could do that. So today, this speech, this lecture is regarded as the starting point of nanotechnology. But he didn't use the term. The term itself was coined in 1974 by a Japanese guy, Norio Taniguchi, and he just meant by it an extrapolation of microtechnology. He said, well, someday in the 80s we will move to the next smaller dimension. But then he never appeared again as a nanotechnologist, so it's a bit funny because he was never in nanotechnology really. Okay, what is this all about? This is the truth. Well, it's kind of my private investigation on nanotechnology. Consists of 5 parts. The first one, of course, is what is it? What is nanotechnology? The second, what can already be done with it? Very important third one, what does not work yet? Because sometimes I think it's a bit difficult to see what's really fact and what is still fiction. Very important question, part 4, is how hazardous is nanotechnology? Because like all technologies, it's not just there and you can do nice things with it. And 5th is just, it's 2 short ideas how we could use nanotechnology for sustainable development, which is not the dominant perspective that people have. Mostly it's industry-driven and it's public-funded research, and what they, of course, have in mind is that they want to create new markets. So let's start with a definition. It's very important that you realize that it is not just another singular technology that deals with a certain object. Like, say, you have biotechnology dealing with all things that are happening within cells. I'd say it's more like a new phase of technology by itself. So the common definition is that nanotechnology means all processes or technical processes that deliberately create or use structures smaller than 100 nanometers, where quantum effects support new handling of matter. And this is just the culmination where different technologies that have been around for some decades merged together in the past, let's say, 15 years. So I think you have to have in mind this broad definition of nanotechnology to really understand what is so special about it. Otherwise, you could hear sometimes scientists arguing, Well, but this is only chemistry. We have been doing that for 50 years, so there's nothing new about it. That's not really true. A very important guy for the development of nanotechnology was Gerd Binnig, who invented the first real nanotool. I will show you that a bit later. And he says, at this moment, man is witnessing and shaping a second genesis, a fundamentally new evolution of material structures, which is a very poetic way to put it. But I think it is no exaggeration. Just to give you an idea what it means, a nanometer is a billionth of a meter or a millionth of a millimeter. And you see here in the left column some diameters of objects expressed in nanometers. So you see the diameter of the moon is 3.5 quadrillion nanometers. And then it goes down to the nanoscale, to the real nanoscale. The scale where we talk of nanotechnology is that what is shown in red. And there you see a lot of natural things, a virus, the ribosome, but also some artificial things like quantum dots or the nanotube. I think this is one of the most known things in nanotechnology. I will show you that a bit later. And then the smallest thing is the hydrogen atom, which is only 1/10 of a nanometer. Let's have a look at the ribosome. You could say this is a natural nanofactory. It's within everybody sitting down there in your cells, assembling the proteins from amino acids. Of course, this is a perspective that we have today. 100 years ago, nobody would have said of the ribosome that it's a kind of a factory. But from that, you can see that through nanotechnology, the way in which we look at life is also changing. Life is now seen more like a kind of machinery, which has been approaching in the past 50 years. The diameter is 20 nanometers, so it's really quite small. And a bacterium has about 5,000 to 20,000 of these ribosomes in the cell, within itself. And they can assemble 10 amino acids per second, so that's already quite fast. And this is something that the nanotechnologists can't do yet. They would like to do that, but they have no idea how to build something as complex as a ribosome. But they have some tools already. So for our familiar way at looking tools, let's just group them together like sensing, grasping, and moving. They have particular kinds of microscopes. But you have to bear in mind that it's not an ordinary microscope. There's nothing really that you see there. All these pictures are generated by computers. They are translated from measurements. But then, at the same time, sensing, grasping, and moving is all done with the same tool. For joining, you have the physical principle of self-organization and, of course, chemical bonds. Unfortunately, it's the only tool they have at the moment, and this is creating a few problems. Well, for cutting, although it's a bit funny to talk about cutting when you're already down there at atoms and molecules, because it's not really cutting with a knife or something like that, but just to take things apart, you have things like the ultraviolet lithography. Lithography is usually used to produce processors. But then if you want to produce really small features, let's say 10 nanometers, 20, you have to use light with a very short wavelength. And in EUV lithography, it's about 11 to 14, because the size of the feature that you can make with light, which is just like making a photograph, similar to that, is half of the wavelength. So if you use visible light, like let's say 400 nanometers, then you come down only to 200 nanometers feature size, which is not nanotechnology. It's just too big. So Gerd Binnig and Heinrich Rohrer, they worked at ABM in the late 70s. They invented the scanning tunneling microscope, and you could say it's like a Swiss knife of nanotechnology because you can do a lot of things with that. It took them 27 months to have the first measurement with this tool. And originally they wanted to do something completely different, as it is quite often in science. So it was more like a random discovery or random invention. But what they discovered is, if you look at the left picture, you see this tip. And you see at the end of the tip, there's only one atom left. And then you have a metal substrate, something that is electrically conductive. And if it's close enough, what happens is that you have one of the quantum effects I mentioned, that is a so-called tunneling current. That means by the laws of quantum mechanics, it can happen that an electron more or less jumps from the tip to the substrate, even if they are not in touch with each other. It's like in the macro world, you have nothing like that. You could compare it to somebody in a prison cell, that there is no probability that he will wake up the next morning outside of the cell, because there's the wall. He can't get through the wall. In quantum mechanics, there is a tiny probability that a particle jumps out of a cage. So that happens sometimes. And what they use is that from the intensity of this tunneling current, they can calculate the distance. And so the tip just follows the substrate surface, and then they keep the current at the same level, and then the whole tip goes up and down according to this current that they have fixed. And what you get by that is like a topographical map of atoms. You can really, you can not only make a 2D picture, you could do all that already with electron microscopes, but this time you can have like something, you can see the heights of the atoms, like this one that is a bit above the rest. And you can also use this one not only to make images of atom surfaces, you can also use this in the sense that that sometimes there is a chemical bond that arises between this one higher atom and the tip, and then you can just drag this atom across the surface. And maybe just for somebody who likes to do things himself, there's a website where is a whole DIY manual how to build a scanning tunneling microscope for about €1,000 if you buy all these parts. Normally it's more like 10,000 up to 50,000 euro. So it's already a technology that could be used by anybody if he has €1,000, of course. This manipulation mode, what I told you, that you drag around atoms, that was discovered just by chance as well in 1989, and I think most of you will have seen these pictures because they are quite famous. They are like pictograms of nanotechnology. What you see in the lower picture on the left is IBM, because it was in an IBM laboratory in Almaden in California. And they were just playing around a little bit. They wanted just to take pictures of a platinum surface, and then they had xenon atoms on the surface. And then they just by chance discovered that they can move them. And so they started writing IBM with 35 xenon atoms on a platinum surface. Later, they made funny other pictures like this quantum corral on the right. That was more like a proof of principle, where you could see, okay, what Richard Feynman said in 1959, you can move atoms really. Before that, you couldn't do that. From the chemistry side,